Welcome back. In this audio, we're going to learn about obtaining the quartiles using the fractal method, which is different from the method we have in our book by Johnson. We're going to order our data, but there's just going to be a small variation. In order to find the index or the location of whatever percentile we're looking at, we're going to take that percent and multiply it by 1 greater than the number that's in our data set. That's going to give us a number, and we're going to use that number in order to find our percentage, quartile, whatever. So I'm going to take this and I'm actually going to show you how to use this method. The first thing that we have to do is we have to order our data set. So I'm going to grab my data values. I'm going to copy them, paste them here, and then I'm going to go in. Remember that I have to take these, go to my sort, go from smallest to largest. I want to continue with the current selection. I don't want any more because I just want to sort that column. So now I've got my data that's ordered, and now I have that X1 is 66, X2 is 77, X3 is 79. So these are the indexes or the positions of my data. Now it's time to figure out what percentile I want and how to find an index and how to get the value of whatever percentile. So I'm going to use the 30th percentile, and then I'm going to go and find our first quartile. So let's start with the 30th percentile. So when I do the calculation to find the index, I do 0.3 times my sample space, which is 12 plus 1, and I get 3.9. Now this is how I'm going to find the location of my quartile, and to find here's the way that I'm going to find my 30th percentile. So in order to find what my 30th percentile is, I'm going to take my third data value. That is the number that comes before the decimal place. That's going to be my third data value, plus 90% of the fourth data value minus the third data value, and that would give me my 30th percentile. So here we see our third data value is 79. We're going to add to that 90% of the difference between the fourth data value, which is 85, minus 79. And our answer is, for the 30th percentile, is 84.4. Now let's look at a comparison with the Johnson's method. With the Johnson's method, we would find our 30th percentile this way. So here we have the Johnson's method, where we find the percentile index, the 30th percentile index. It's just your percentile, percent, times how many are in your data set. So I get 3.6. And remember, they would say if it's not an integer, you just go to the next greatest number, and that would be the index of that particular percentile that you're looking at. So we would go to the fourth data value, which is 85. So using the Johnson's method, our 30th percentile was 85, whereas using the fractile it was 84.4. Now let's look at finding the 25th percentile. And so this is finding the first quartile using the fractile method, where I find my index by 0.25 times the data values. We have 12 data values plus 1, so that's 13, so I'd get 3.25. So the way that I'd find my 25th percentile is I'd take my third data value, add to that 0.25, the remaining, the decimal of that index, times the fourth data value minus the third data value. And then I'd get that my 25th percentile is 80.5. And using the Johnson's method, getting the index of 3, and remember if the number comes out an integer, then we need to take the average of that number plus that indexed data value, so x3 plus the 1 greater x4, and average those out to get that percentile. So we take 79 plus 85 divided by 2, and that gives us 82 for the 25th percentile. I'm going to change the data up just a little bit to show you the sensitivity of the fractile method. Now we're going to look at an example where we have 9 in our sample space, and knowing that not all data sets are evenly distributed across their ranges. So we're going to just take that same data set though and just lop off a couple of data values. So let's look at the fractal method for the 30th percentile. We see that we get using the method, when we multiplied 0.3 times 1 greater than the data set, since there were 9, we add 1, that's 10. So our index would be 3.0. So we take our third data value plus 0 minus the difference between the next data value up minus its data value, which of course is 0. So our 30th percentile is 79. And when we use the fractile method to find the 25th percentile, we do the same thing. We get 2.5. So that means we take our second data value and add to that 0.5 times the difference of the second data value from the third data value. So we get the 25th percentile to be 78. Now when we use the Johnson's method, we see that there is no difference between the 30th percentile and the 25th. Both are 79. So the fractile method is a bit more discriminating in establishing the percentiles. So here are two different examples of using and the difference between the Johnson and the fractile method. I hope this helps. Thanks for listening.